So 10/4 is common logarithms. And like I said, we're going to use our calculator now. And this is the part where we can have different bases and we can fix that sort of thing. So a common logarithm is a base 10 logarithm. So it's like y equals log base 10 of x. You will notice that you sometimes don't see that 10 anymore. So look here at number 1. See how it doesn't have a base anymore? That's assumed to be a 10. Okay? So think about it as like a square root. If you don't see an index, we assume him to be a 2, right? So same thing with a logarithm. If you don't see a base, we assume him to be a 10. Now, good news for you. I'm not going to give you a log chart. This is just a whole bunch of jazz that we used to do. So we're not doing 1 and 2, and I'm not going to give you a log chart. Let's make your life easier right now, right? And mine. That felt good, right? Scribble through some of that. Okay. Let's go down here to number 3. It says solve 5 to the x equals 62. Okay, so when we were doing these before, we were trying to get the 5 and the 62 to have the same base. This thing has a mind of its own today. All right, can I ever rewrite 5 with a base, or excuse me, 62 with a base of 5? No, it's going to be gross, right? So instead what I'm going to do is I'm now going to use that log rule that we had. Whoop, gotta find him. This guy right here. That said if I take the log of both sides, or I have something with an exponent, he can come down out front as a coefficient. So what I'm going to do now is I'm going to take the log of both sides of this equation. So I have log of 5, and I don't have to put a base because I'm assuming him to be a 10, equals log of 62. Remember when we got rid of them before, there was one on each side with the same base, and we got rid of them. I'm putting him back. Okay? Now, that exponent can come down as a coefficient. So this is x times log of 5 equals log of 62. You're going to say, how the heck are we going to solve that? We're going to use our calculator. So, here we go. Let's investigate our calculator a little bit. Notice that you've got this log button right here next to the 7. Find your log button. When you put that button in your calculator, it's assuming it to be a 10. So your calculator works on log base 10. He works on common logs. Okay, so what we're going to do now is we're going to put that 5, log of 5, into our calculator and get his decimal approximation. Okay, let's do that. Log of 5. Let's go to 4 decimal places. We're going to work through 4 decimal places for all of these. So, how many of you want to put your calculator and hold it to 4? If you want to do that so you don't have to think about rounding, hit mode. This is totally optional. If you're not a fan of rounding, and your calculator will do it for you. Hit mode and see where it says float right there. You can fix the number of decimal places it gives you. So if you want it to always give you 4, set it on 4. Okay? If you don't like it, you don't have to do that. I'm going to set it on. No, I'm going to float. Okay, so now let's change this guy to 4 decimal places. Ooh, this one's a tricky one. 6990, yep. So this is x times 0.6990 equals, and I'm going to do the same thing with 62. 1.7924. Bless him. We just turned this guy into an Algebra 1 problem, right? Because now I just have this decimal of 0.6990x equals 1.7924. How do I solve for x? Divide. So x equals, now depending on how you carry it through and how you drop it off and things like that, you might be slightly different, and that's okay. This guy's still in my calculator. I'm just going to carry him through instead of typing in crazy decimals all the time. Does that make sense? So I'm just going to hit divided by 0.6990. Remember, we've rounded that guy, so you should get close. The only part that should be off should be the last two digits. That's all. When I did it in my notes on before, I got 4.3. Does that make sense? So you should be close, but it depends on how you chop it off, round it, and carry it through your calculator. The first three digits should be very similar, though. Okay, let's check it. That means that 5 to the 2.5642 should be about 62. Blake says, yes, we did a good job. I got 61.9867. Close enough for me, right? Questions? Okay, let's try 4. Are the bases the same? No, so I can't get rid of them. So I have to take the log of both sides. So log of 2 to the 7x is greater than log of 3 to the 5x minus 3. There's exponents. They come on down out front. So 7x times the log of 2 is greater than 5x minus 3 times the log of 3. Okay, let's put that log in our calculator. Log of 2. This is 7x times 0.3010. Log of 3, 0.4771. I think the trickiest part with these is getting caught up in all of the decimals. This guy is still in my calculator, so I'm just going to multiply. Now, let's not do that. Let's do 7 times 0.3010. Here I go. And I get 2.1070x is greater than, and I have to distribute this. 0.4771 times 5. 2.3855x minus 4771 times 3, 1.4313. There's an x and there's an x, so let's combine them. .1070 minus 2.3855. Negative 0.2785 is x is greater than negative 1.4313. What do we have to remember to do with this guy?
Flip the sign.
Yep, we gotta flip our inequality. We're dividing by a negative. So x is now less than 5.1393. Like I said, it should be close. You should have gotten close to that.
Yep.
Okay, how about you try 16? No, 5 with the 16 out front there. See if you can try 5. There's no way I can make a 16 with a base of 3. So I'm going to take the log of both sides. You should get close to 3.7162. Don't forget to distribute. Okay, now I'm going to combine my D's. The tricky one is, I think the tricky part with these guys is making sure you type it in your calculator correctly. Which I don't think I typed that one in right. Oh, maybe I did. I got 3.5995. I don't know if I typed it in correctly or not.
I got 3.7162.
Perfect. I love it. But I may have messed up with my numbers. Yeah, I did. That one's not right. I did 117. Oy, oy, oy. 1.4313. Which means that number changes. Yes, I got 3.7162. As long as you're close to that, I'm a happy lady. It shouldn't be like 4. Does that make sense? So it should be 3.7 something. That's how close it should be. Does that make sense? Questions on any of those? Okay. Depending on your calculator can do different bases. Okay? So at the bottom of your paper there, it gives you a change of base formula. And the change of base formula says log base A of n is equal to log base B of whatever you want it to be of n divided by log base B of A. Okay? Now, however, most of you, or some of you, have calculators where you can do a different base. If you have one like mine, and it's the skinny yellow one or skinny whatever, you do have a different base. Okay? So, I want to show you how to do a different base on your calculator. If you hit the math button, which is below the green alpha button, if you scroll up a few times, you should see something that says log base. If you scroll through that whole one right there and it doesn't have it on there, then you don't have this capability, okay? So, if you pop that guy in there, now I can do a different base. See that guy right there? He gave you the subscript and he gave you that guy. Does anybody not have this? Okay, I will come look at your calculator, okay? I'll come look at yours too, okay? All right, so Wyatt, I think yours is in there too somewhere, but maybe not. I'll show you how to do it without it, because you don't actually need this part. So log base 3 of 18, if I put this guy in my calculator, I can change him like that and get 2.6309, okay? If you don't have that, we can use this change of base formula. So Mitchell and Wyatt and Thomas, just go ahead and watch, okay? So we can change it to whatever base we want by taking this guy on top divided by the log of that guy. So for this one, it would be the log of 18 divided by the log of 3. And I don't have to put a base because I'm going to go straight to 10 so I can use my calculator. Okay, so if I do that in my calculator, now we'll just hit the plain log button by the 7 of 18. Make sure you close your parenthesis. Divided by the log of 3. Make sure you close your parenthesis. So this guy is 2.6309. If you have that log base where you're able to change it in your calculator, you go ahead and do that. Yes.
logarithmic approximation. I just thought about that. Sideways parabolas, you can plug in a line. What is I can grasp it. I think that's what that's why do so bad. I got like one night. I was like, I don't even try. I literally just I literally circle in a circle in a circle like random.
Okay, see if you can do the other two ones. See if you can do B and C on your notes. Okay, so on B, you should be able to just type those two in your calculator. Again, the two different methods. Log base 2 of 13, 3.7004, or if you don't have that, log 13, close your parentheses, divided by log 2. And then the last one, you should get 0.8271. Sound good? Okay. Look at your notes. Let's go to your worksheet now. Sorry, look at your worksheet. I chopped the part of the middle out of this worksheet. Yeah. 5 through 8. Maybe you needed that for workspace, yeah. Okay, so 1 through 4, you're just typing those in your calculator, tell me 4 decimal places. Same thing with 23 through 26 down at the bottom. Okay? Then the ones in the middle, you're using that come on down rule so that you can solve these guys to 4 decimal places. Griven's just going to guess 4 decimal places. I got this.
I need like 4 days on my test.
Okay? Questions? You're good? All right.